Okay, so this will be our next set of example. We are still in series parallel and parallel series. Okay, so in the first problem, you are required here to obtain the total resistance. Okay, if you are given a problem like this, all you have to do is to simplify. How do you simplify? You try to reduce the connections, no? You compress the connections. In what part you will be compressing? Ito. You try to compress in these parts as well as in this one, so that it will look like this. Okay, yan. Okay, so this is our total resistance. This is our 2 ohms, 3 ohms, 4 and 5. So you can now analyze and recognize which one are connected in parallel and in series. 2 and 3 are in parallel, 4 and 5 are also in parallel. The resistance of 2 and 3 in parallel as well as 4 and 5 in parallel are okay, 2 and 3 in parallel is equivalent to 1.2. Okay, 1.2 ohms. And 4 and 5 in parallel is 2.222 ohms. Okay, and redrawing this one further will give you this figure. Okay, this is 1.2. That is 2.222 ohms. This is your total resistance. So total resistance out of this is 1.2 plus 2.222 is equivalent to 3.422 ohms. Okay? Yan. Can you follow? This will be very easy to recognize. Okay? So if you can follow, let's proceed with the second problem for number 2. Okay? How about in problem number 2? How we're going to obtain the total resistance that is required. This is the total resistance. Okay? So let us try to redraw the figure, compressing the connection points. We will try to compress this part as well as this and this one. So if we try to redraw that slowly, for problem number 2 will look like this. Ganyan. Okay, this will be ganyan. Okay, this will be your 2 ohms, 3 ohms, 4 and 5. So if this particular part is short-circuited, you try to redraw it again. Compressing your 2 ohms. Okay? This is your 2 ohms. We have the your 3 and 5. 3, 5, and 4. And this is your total resistance. This time, your 2 ohms will be put out of the question, and the total resistance is just the parallel combination of 4 ohms and the series combination of 3 and 5. Correct? Or, if you are accustomed to this formula, 1 all over R total is equivalent to 1 over 4 plus 1 all over 3 plus 5. The result will be the same. R total, yan. Okay? We try to solve that. The total resistance is 2.667. 2.667 ohms. Problem number 3. Just the same, we will try to compress this short-circuited part. Yan. As well as this. Compress natin ang mga to. Yan. Okay, we try to compress that. Okay. Ito yung terminal, this is the terminal of 3 that will be shorted out. This is your 5, 2, 4. Okay. This is your 3, 2, 5, 4. Okay, saan ba nakakonect ang 5? Doon. Ito, this one. Correct? And this will be the other terminal. So if this is your other terminal, this one is your other terminal. Okay, 2, 3, 4, and 5. You will see from the diagram that your 4 ohms is also short-circuited. So this is out of the circuit. This is also out of the circuit. So redrawing this, again, will give you 2 ohms, 5. This is your other terminal. That is where the total resistance is to be determined, which is by inspection is the parallel combination of 2 and 5. So 1 all over R total is 1/2 plus 1 all over 5. R total is, okay, total resistance (1.429) 1.429 ohms. Okay? Yan lang ang gagawin mo. You will be finding for the total resistance. So I guess we can already proceed in our first topic in circuits. Or do you need more examples in series parallel? I already have given you lots of examples.